Hey guys, so we're starting 1D, which is all about area and volume. You really want to look at some of the vocab because it is a lot of the formulas that we're going to be using in these examples. But let's dive into the examples for now. Example 1, it says determine the base area and the volume of the figures. Always start by determining the base area. It's super helpful. So if I look at example 1, the base is it's the top or the bottom. Doesn't matter for prisms, right? So this is a rectangle, and it sometimes helps to write that if this is 7, then this is 7. Okay. So since this is a rectangle, my area of the base, right? For a rectangle, it's just length times width, which here is 7 times 15. Okay. So my area of the base is 105 inches squared. And I know it's inches squared because we are only looking at a two-dimensional flat object, right? As soon as I get into volume, which we're going to do now, right? So volume takes that base and fills in the rest of the shape by placing it on top of each other a whole bunch of times, right? It's just like that rectangle has been stacked up, right? So then the volume of, this is a prism, right? It's a rectangular prism, is the area times the height. Okay. So that's 105 times, and my height here is 4. So the volume of this prism is 105 times 4, which is 420. And this is inches, and now it's inches cubed because it's a three-dimensional object. Okay. All right, let's look at example B. All right, it's the same other thing. I have a base down here. Sometimes they don't mark them as well, but this would be like a rectangular base down at the bottom, just like it's a rectangular up at the top. Okay, so same thing. My area of the base equals, I have length times width. So that's 10.5, 7.3. And when I multiply those together, I get 76.65. So that's, and then again, this is just a flat two-dimensional object, so feet squared. 76.65 feet squared. So now for my volume, right, again, my volume is just now I'm placing that base on top of each other a whole bunch of times to build it up. So then my volume equals the area times the height. So my area is 76.65 times my height, which is 16.8. And when I multiply those together, I get 1287.72. So 1287.72. And now this is a three-dimensional object, so it's feet cubed. All right, looking at C. I'll bring that. Now this is a triangle. Right. So the area of the base is 1/2 length. It's kind of like length times width. But make sure they're meeting at that right angle. Like, right, I have that right angle here. So you have to use the pieces that are for a triangle that are meeting at a right angle. So yeah, I'm finding just this base here. So I have 5 as like my length or width, whichever one, and 11 is my other measurement. So that's 1/2 times 5 times 11. So when I multiply all that together, my area is 27.5 feet squared. Then to find my volume, again, I'm just stacking a bunch of those on top of each other. So my volume equals the area times the height, right? I'm stacking a bunch of those on top of each other to get this whole height. So I have 27.5 times 8. And that equals 220, and now it's feet cubed. Alright, then I have, right, a cylinder. So now I start with the area of a circle. The area of my base is pi r squared. Right, and my r is that radius. So I have pi times 22 squared. And when I do 22 squared, I get 484 pi. And it is standard for the number to go in front of the pi. And then pi is just a number, and I still need to put my units, inches squared. Now, when I'm finding the volume, I'm filling in the rest of the cylinder, right? I'm stacking all those circles on top of each other. So, the volume of my cylinder equals, right, the area times the height, which is 484 pi times 35. And when I multiply those, I get 16,940 pi inches cubed. So 16,940 pi inches cubed. Alright, then now I'm getting into cones and pyramids. The only thing that changes with these is I'm not completely stacking the whole thing by its height. I'm taking 1/3 of it every time. Well, not every time, but I'm multiplying the whole thing by 1/3. So, for this one, again, we start with that base. So here my base is a circle. So the area of a circle equals, right, pi r squared. Now this is where you have to be careful because the radius is just half of my circle. Right? And here, that 14.4 measurement, I can tell by all the dots, is the whole circle. So I have to take this measurement and do 14.4 over 2, which is 7.2 is my radius. Okay? So this equals pi times 7.2 squared. So my area of that circle is 51.84. And this is feet squared. Then when I'm finding the volume for a cone, right, when they slant in, is 1/3 times the area times the height, right? So that's really the big thing you have to remember the difference for. So I have 1/3 times 51.84 times 13.1. And then when I multiply all of those, I get 226.4 approximately. I rounded a little bit. And this is feet cubed. Okay. Alright, then for F, right, again, this rectangle is my base. So I have to start by finding the area of my base, which equals 24 times 8. which equals 192 centimeters squared. Then again, for my volume, I'm finding all of this. So volume equals, again, since it's slanted in, it's just 1/3 of that square being, or rectangle being stacked on top of each other. So times area times height. So 1/3 times 192 times 22. And when I multiply all of those things together, I get 1,408. And this is centimeters cubed. Alright, the last thing we're going to look at is these last three problems, which just has to do with Cavalari's principle. Right, all these are slightly slanted. The one thing to remember, and what we're going to use Cavalari's principle for, is that if they're slanted, it doesn't matter. Right? So let's look at this first one. Here's my base. What this is saying, you can see little tick marks in it, is that this is a square. So for the area of my base, it just equals 4 times 4. Those are all they're all the same. So my base is 16 feet squared. Right? It's just a two-dimensional object. Then for my volume, filling all this in, right, even though it's slanted, the height, right, is still 6 feet. So just think if I push this up, it'd look exactly the same. So my volume is still the area times the height. So 16 times 6. So my volume is just 96 feet squared, or feet cubed. Always, let's make it nicer. Because it's a three-dimensional object. So even though it's slanted, we still just can find the volume. Alright, looking at B, this is a cylinder, but it's still the same type of thing. So my area of that circle, right, be careful, because I have to divide this by 2 to get the radius. So equals pi times 2.5 squared. Right? And 2.5 squared is 6.25, and then can't forget that pi. And this is meters squared. So to find my volume, and since this is just a cylinder, it's just area times height. The sides aren't slanted together, right? They don't come to that tip, that point. So this would be 6.25 pi times my height, which is 6. Because again, you can just kind of push that up. When I multiply those, I get 37.5 pi meters cubed. Alright, and last but not least, C. Again, my base is a circle. Okay. This 36 is still, since it's the whole dotted line across, I still have to divide it by 2. So 18 centimeters is actually my radius. So the area of that circle equals pi 18 squared. I don't care that this part isn't over the middle. All of these are slightly off center, right? They're slanted one way or the other. So that doesn't affect anything. It's still a circle. Okay? So then my area is 324 pi centimeters squared. Alright, so then for my volume, right, this one, there's a point up here, right? They meet at a point. So it's the 1/3 one times the area times the height. That's a really bad A. Okay. So that's 1/3 times 324 pi times 15. So when I multiply all those together, I get 1,620 centimeters cubed. Alright, so that's all we're going to look at for volume today. Tomorrow we'll look at a little bit more of complex figures and figure out their volume. See you guys tomorrow.